Hi, my name is Greg Mitchell. I'm going to be giving an overview of our paper recently published in the Journal of Animal Ecology titled Timing of Breeding Carries Over to Influence Migratory Departure in a Songbird, an automated radio tracking study, co-authored by myself, Amy Newman, Martin Wikelski, and Ryan Norris. Carryover effects represent events or processes in one season that carry over to influence individual success or fitness in a subsequent season. For example, low food availability during the winter might carry over to affect reproductive success the following spring. One mechanism resulting in carryover effects are time constraints. For example, migratory birds require a specific amount of time once they are finished breeding to replace their feathers and build sufficient fat reserves for their impending fall migration. This suggests that timing of breeding completion in adults and fledgling date in juveniles might carry over to affect timing of migration. We tested this hypothesis in a migratory population of Savannah sparrows. Our research took place at the Bowdoin Scientific Research Station on Kent Island, New Brunswick, Canada. Kent Island is part of the Graham and Ann Archipelago in the Bay of Fundy and is located approximately 50 kilometers southeast of the New Brunswick-Maine border. Over 2 years, from late May to early August, we recorded the breeding history of our study population, including the date at which adults were finished breeding, as well as the date when nestlings left their nest. Following breeding, in September and October, we captured both adults and juveniles and fitted them with miniature-coded digital radio transmitters. We then used an automated digital telemetry array comprised of 3 towers to measure the exact minute an individual left on migration. This is illustrated by the loss of signal in the plot on the right. If we zoom in on the evening where we lost the signal, we see a characteristic spike in the signal when the bird takes flight, followed by a decrease in the signal as the bird flies out of range. Our automated array revealed that timing of breeding completion for adults and fledgling date for juveniles were strong predictors of the date an individual would depart over 2 months later. We also examined the weather conditions under which individuals chose to depart. In this image, the light gray and colored pixels represent cloud cover. We found that both adults and juveniles avoided departing during low pressure conditions characterized by rain and overcast skies. However, as low pressure systems moved off to the east and high pressure systems approached from the west, characterized by northerly winds and clear skies, both adults and juveniles would readily depart. Interestingly, although both age groups would leave on the front half of a high pressure system, only juveniles chose to depart on the back half of high pressure systems, indicating that they were less choosy about departure conditions. After accounting for breeding history and weather conditions, we could almost predict the exact date an adult would depart on migration. However, because juveniles were less choosy about departure conditions, weather did not improve our ability to predict departure dates in this age group. So in summary, we found that timing of breeding events carried over to affect the approximate date an individual would leave on migration, but that this date was fine-tuned by local weather conditions in adults, but not juveniles. Understanding the factors affecting when individuals leave on migration is important, given the hypothesized relationship between timing of migration and survival.